Okay, so last week, I'm trying to get track of time. Last week, we announced the UXL Foundation. So UXL stands for Unified Acceleration Foundation. So slightly interesting acronym there, but that's what it means, Unified Acceleration Foundation. And that was done with lots of industry partners. So that was Arm, Fujitsu, Google Cloud, Imagination Technologies, Intel, Qualcomm, and Samsung. So you'll notice most of those are chip companies designing their own chips. So you can see this is partly about being able to write software once and running on lots of different devices. You'll also notice that some of those companies target very different kinds of machines. Intel talks a lot about supercomputers and data center, but there's also client PCs. But within some of these companies, it's not just supercomputing. Some of it is about cars. Some of it's about embedded devices, things like that. So anywhere where you want to get code from the CPU onto accelerators and get more performance, whether you're doing AI or graphics or something else, but about accelerating performance, that's what it's about. So the mission is to build a multi-architecture, multi-vendor programming ecosystem for all accelerators and unify the heterogeneous compute ecosystem around open standards. So I think it probably sounds a bit vague when we describe it like that. And because the foundation has just been announced, we're working through a lot of the details as a group. The purpose of the foundation was really to create open industry governance. So when we're saying it's about multi-architecture, multi-vendor, then the foundation is making decisions rather than one organization making the decisions. You'll see that focus areas, AI, high-performance computing, edge AI, edge compute, and a lot about open source. And there's a few comments that we've got from different people who are involved in it in different ways. The members here are the founding members who govern the steering committee, but actually the UXL Foundation is under the umbrella of the Linux Foundation and it follows Linux Foundation rules. So anyone can join. It's a very open foundation. And so that means it's going to be very focused on open source. A lot of it is based around the SYCL programming model standard. I was chair of that group many years ago when we started it. SYCL is a way of programming C++ for accelerators. So if you're used to programming C++, you can get it onto accelerators, but it's not just about programming in C++, UXL. We're going to use various different things, open source projects to integrate different projects together. We are not, I want to make one thing clear. Our intention is not to compete with SYCL. So we will work with the SYCL standard for C++ programming models. And there's an ongoing discussion about how that will work. The difference is the SYCL standard is a specification. It specifies how to implement SYCL. And there are multiple implementations of SYCL. One of them, amazing academic at Heidelberg University, and a small number of students have created what's now called the Adaptive SYCL project. They've done various versions of that with different names, but incredible project. We at Codeplay did a version called Compute CPP, and Intel has a version called DPC++. So it's a specification. SYCL is a specification. It's not an implementation. Am I seeing comments from the developers? Yeah, amazing developers out. So SYCL is the language specification where you should be able to compile with multiple compilers. The difference between the way Khronos works and UXL Foundation works is that Khronos is very much aimed around specifications that are going to provide an interface between hardware and software. And that just makes it a little bit harder to get involved. I do encourage people to get involved, but it can be a little bit harder. The process is more about those specifications. Whereas in the UXL Foundation, we're going to focus more on the open source ecosystem. And the group is going to make the decision about what gets included in that. Now, Intel is contributing its One API work, but that doesn't necessarily mean that the decision is made to use the One API name or use all of the One API implementations in this form. it's going to behave very much like the Linux Foundation in managing open source projects. That's what it's about. And you can very easily get involved in the UXL Foundation and start to talk about what you might want as a developer, or if you're designing your own hardware, you can join and talk about it. But our starting point from the One API specification is DPC++ is the SYCL implementation that Intel developed. It is an implementation of the SYCL standard. I think in some of the early days, there was an implication that it might deviate from the standard a bit. There's much more of a strategy now around sticking to the standard. And I think that's an excellent thing. And you'll hear extremely senior executives in Intel being very committed to sticking to the standard. Next project is called 1DPL, which I think is at a much earlier stage, but I'm really excited about this project, and I'm actually going to give you some slides on it because I think it's a really cool thing. What SYCL lets you do is write code in C++ and then run it on lots of architectures. Now, the question you're going to have, if you're interested in optimization, is it going to be fast on all of those architectures? And the answer is SYCL does not promise to make your code run fast on all architectures. However, there are C++ programming techniques that allow you to achieve portability. Lots of people do this. They've been doing it for a while. We saw it a lot in video games. We've seen it in supercomputing. These libraries called Cocos and Raja that do that. They're open source. They use C++ compilers underneath. There's libraries in AI, particularly Eigen has been around for a while. That's used in TensorFlow that does these techniques. What we've done with 1DPL is we've standardized that a lot. It's open source, and we are making that optimized for various different GPUs and devices. And as part of the UXL Foundation, you'll be able to submit pull requests to be able to optimize it for other libraries as well. So I'm really enthusiastic about that, and that's based around the parallel C++ standard as well. We've got 1DNN, which is for doing neural network operations in an optimized way. We've got 1CCL, which is really for it's really aimed at data center applications where you plug multiple accelerators into a system. You can plug multiple GPUs into a system, and then they can communicate between each other. And they don't just communicate between each other; they actually do all sorts of smart operations within the networking system to be able to combine results from different GPUs very efficiently. So 1CCL does that for you. We've got level 0, which is the very low-level API to be able to interface to hardware. I think it's going to be an interesting discussion to work out what is going to be the kind of universal hardware interface for the UXL Foundation. That's one of the discussions we're going to be having. Got 1DAO for data analytics, 1TBB, which is threaded building blocks, which is one of the early C++ libraries that took on these performance portability techniques. So I'm keen on that, but I think that's mostly focused on CPUs, but we've taken a lot of those ideas into things like 1DPL. And finally, we've got 1MKL, which is the high performance math kernel library, which does things like matrix multiplies and fast Fourier transforms and stuff like that. But this is the starting point. It could change because it's all about the governance. So it's under the Joint Development Foundation framework with the Linux Foundation. And it's designed to encourage broad-based industry participation and contribution. So you can pay money and become a member, and you can become a member without paying money. I think if you go to the website, you don't get a lot of information right now because it's just launched, but it is possible to do that. We are sorting that out. We will fix that soon so it becomes much clearer how you get involved in the SIGs. I think some of the people on this call are already involved in the SIGs. If you're involved in the One API ones, you'll continue on to the UXL ones. So those are special interest groups and then working groups. And then you'll see that there's open source projects that are being governed as well as specifications.
Hey, Andrew.
Yes.
Could you just kind of lean a little bit closer to the microphone? You kind of fade in and out when you're talking. Thanks.
Am I? Oh, I'm sorry.
Yeah, no worries.
I'm using headphones, so normally they work. Can you hear me well now? I'm hoping this is working.
Yes. Yes.
Okay.
Sound great. Thank you.
Yeah. So expect this to work much more like an open source project where people can get involved. And my hope is that we get a lot of these technologies upstreamed into other projects like Linux distributions and frameworks and things like that. So I'm really hopeful that what happens is we make a fully open source stack available to everyone. I suspect that a lot of the people involved in this will want to add their own special secret sauce, their closed source contributions that will make things go faster or better or give you better tools. But fundamentally, the UXL Foundation is going to have a fully open source system. And that means you as a developer will be able to make use of a fully open source system. And then we need to work out how people can make their special hardware-specific optimizations work well on hardware without breaking everything. That's going to be something that we'll be discussing. But it is going to solve a fundamental problem that right now it's very difficult to ship open source software if it uses GPUs or accelerators, because you're dependent on some closed source stuff. And now we're going to fix that. I think that's going to make all of this much more available to more people. That's my big aim with this. Okay. So I'm now going to talk about the One API ecosystem. I'm not mentioning UXL just because this is the work that we've been doing, but this is what's being fed into UXL Foundation.
Hey, Andrew,
yes.
I have a general question on the process of how the spec gets updated. Could you maybe so how does the specification get updated within the UXL Foundation structure?
Okay, so that's a really good question. So there, in One API, there was a forum that people could join and they could comment on the specification, and then Intel people like Robert Cohn would actually update the specification. And then the developers would go off and implement the specification. Now, as UXL Foundation, I think my prediction is that where we'll end up is it will behave much more like an open source project managed by, agile Jiras and sprints and things like that, or more normal kind of open source processes. And then when we will make sure that the specification matches the implementation. That's where I think it's going to go.
Okay.
But it's not my decision.
Yeah.
I'm just kind of describing how it is. Expect it to behave like an open source project. I think that's the direction of travel. But we are actually going through a process of working through what are all the components of One API, what's being provided, and how are we going to take it forward.
Okay, so my next question is, in the process of updating the spec, how does that trickle to the open source project so that implement the spec? Is there some idea how that happens?
So not right now, but I do think that how it was happening is the spec then got implemented, and I think that given where we are now, it's more likely to be that the spec will start to go the other way around. I think the spec will match the open source.
Okay.
That's where I think it will come out. So that good software engineering practice means writing the spec and keeping the spec up to date, but I think it will behave more like an open source project that's moving forwards like an open source project.
Yeah, I think the other thing is we really expect to have a lot of contributions from some of the other committee members that joined, and so we're very excited for those folks to be getting involved. And so as Andrew said, I think that there will be this technical steering committee, and underneath that there will be a working group that'll be working with regard to the spec and open source.
Felix has a question here. I'll read it out. I'd be interested in what the plan to solve the shippable binary problem. We mostly have portable source, but as of now, shipping a single binary that can use SYCL on multiple implementations is between hard and impossible. This is in the message.
Excellent question. And it would be great if you brought that question to the UXL Foundation, because I think that one of the first things that I want to focus on within the UXL Foundation is packaging, for exactly that reason. Yeah. How do we work out? Yeah.
It's like I know you speak with Haskell every now and again, and I see a bit of banter every now and again on Twitter, which is quite funny. but that's been one of the advantages of like adaptive CPP over the other solutions, and it's something that I haven't seen addressed by the One API folks in a long time. And we have source portability, which is great, as long as you stick to purely the SYCL spec. There's been some questions around UXL and One API and taking in the DPC++ exclusive extensions that I'd like to see addressed, but maybe we can talk about that at the end of your talk, and I don't want to derail too early. So, yeah.
Well, this is a very good subject, and I think it's something that we've got to work out. What I would say at the moment is that when we Codeplay compile from One API down to NVIDIA and AMD GPUs, we do it through the entire compiler stack, which means you have to compile explicitly for them. Now, you can integrate multiple binaries within your application, but you have to run the compiler multiple times to get the NVIDIA and AMD kernels compiled along with the Intel kernels compiled. And there's a lot of debate about whether that's the right way of doing things. It does allow you to have that consistent compilation stack from top to bottom and optimize most for each hardware. But yeah, how you ship your program in this multi-vendor, multi-architecture world, I think is a really good question. Some of the organizations will be compiling for something like a car, in which case you know what the hardware is. Some of them will be compiling for a supercomputer, in which case they know what the hardware is. But if you're compiling for a PC, when you're going to plug in a GPU that you don't know what it is, then it's a different question. And managing those different situations is the challenge. Yeah. That's the question. Please bring it.
Will do.
We'll let you continue. So save more questions for the end.
Yeah. How are we doing for time? Right, half an hour. So we've got a lot of One API industry momentum. I used to try and track SYCL industry momentum, and it used to be a very small side with a small number of things, particularly in high performance computing. There has been a massive switch to SYCL. There's been a huge amount of work, and we're able to show a lot of stuff running really, really well with SYCL using this open source stack. So within scientific computing, we've been very successful. We've also got the SYCL work into Blender, which works very well, and you can demonstrate that running on NVIDIA and AMD GPUs, as well as Intel GPUs, which I was doing last week. So really, really pleased. And we now need to achieve that same level in AI and whatever comes next, whatever people do next with high performance. Yeah, so where Codeplay fits in is currently, as we've been taking the open source One API and putting in backends for AMD GPUs and NVIDIA GPUs. So Intel provides the Intel GPUs and the rest of the stack, and then we do plugins for AMD GPUs and NVIDIA GPUs. And you can download that as a binary plugin from our website, or you can check out the source code. We don't just do SYCL because we do the compiler, we do the SYCL compiler, but we've also been porting the libraries, and that's the difference between SYCL and UXL and One API is that we have these libraries as well. So we've been implementing those libraries, and we can support NVIDIA and AMD GPUs using their optimized NVIDIA and AMD libraries like cuBLAS and cuDNN and RockBLAS and RockDNN. And what we do at Codeplay is we enable new hardware. So what we've done over the last year is, when we were an independent company selling to hardware companies, we would do projects using this toolkit. And then what we've done is we've actually open sourced this toolkit and we've documented it. So if you're designing your own accelerator processor, you can just check out the source code for this toolkit and get it working on your own accelerator, and you've got all the instructions to do it. We've seen quite a few people build accelerators out of RISC-V processors. So what happens is you have like maybe an Intel or an ARM or an AMD CPU, and then you have lots of small RISC-V cores on a chip with some extra hardware. So it basically looks like a RISC-V based GPU in effect. And if you look at those companies, there's quite a few of them who've designed it that way. Makes a lot of sense because you're kind of ecosystem ready, but how do you then get the software onto all of those RISC-V processors and use some of the memory systems. What happens with the construction kit is we support that out of the box. So maybe you have to plug in, if you've got DMA units and stuff, you have to customize it a bit, but we can do that. If you've got your own processor design, then you stick in your own LLVM compiler. But we show you how to do that. And so that means if you're designing your own hardware, you can do that open source. So this is one of the projects I'm really excited about because it lets people design lots of innovative hardware and still run real software. We see a lot of people designing really cool hardware and then they can't run software. Well, now you can have an ecosystem. And so we've seen people amazed at how quickly they can get stuff up and running with that. We do a lot with open standards. We've been very involved in the Kronos group defining the SICL standard and now involved in SICL Safety Critical and MISRA. So because people want to be able to use these technologies to drive cars and run medical systems, we got very concerned about safety. So we've been taking the safety very seriously and defining safe versions of these standards. So we're starting to work through all of the safety issues. And that's a really interesting subject. Really interesting subject to try and work through this stuff because sometimes people care about performance and they get maximum performance and don't think too much about safety. Starting to work out, okay, how do we make this safe? Create some interesting questions, especially as we still need huge amounts of performance to achieve what we want to achieve with automotive and medical AI systems. So really interesting field that we're working on. Okay. So I said I was going to talk about 1DPL and performance portability. So I wanted to show these slides because we haven't been talking about this much, and I think it's really cool. So I think this is going to help a lot. Okay, so this is what it looks like. This is kind of PowerPoint style code. If we sum up an array in serial on a CPU. So there you are. You've created a C++ vector. It's very C++y. And it's very C style. We run through the array in serial and set it up. And on old CPUs, that might have been faster. On modern CPUs, 99% of the hardware in the system isn't being used. So how do we make that go fast? Well, with SICL, the obvious way to do it is to do parallel for. And then maybe the stupid way, but I thought I might show it anyway, is to actually add up using an atomic. So we can't sum up in a single sum variable for all of them. So we'll add up an atomic, and what happens is an atomic, make sure that that add happens on the sum or in order, which basically means we start running it in parallel and then we run it in serial. But that atomic allows us to have all the different threads add up to a single sum. It won't be fast, but it does work. So instead, if we wanted to go fast, what we do is we do a parallel for in SICL. And then what we do is we sum up chunks of an array, all in the different threads across our GPU. And then we do an atomic ref at the end where we add up all of the different chunks together. And what that will do is that will give you much better performance. So we sum up as much array as possible in parallel. And then when we have to add up all the values at the end, we do an atomic ref to be able to do that. And this should run reasonably well on a GPU. I'm sure people are going to argue there are better algorithms, but it won't fit in the PowerPoint slide. But you can start to see it gets complicated. We've started to use templates because, if you're adding up a float, it's kind of the same as adding up an int, the same as adding up a complex number or something. So why not template it? So to make it easier, what we did is inside SICL now, we added these reduction algorithms. So here you can see the SICL reduction algorithm. It still adds up the sum here, but we're probably going to hide this. Now, the advantage of using this template approach of doing a SICL reduction in SICL is the SICL compiler may know your hardware, and it may know that there's a special fast way of doing an add. So you can see we've got SICL reduction is like if you're summing up an array, that's called a reduction in abstract terms, and then we say plus because that's the operation that we're implying to all of it. And then the SICL implementation can then distribute the work across all the different cores. So I think that makes the code a lot easier and simpler to write, simpler to read, but also what it does is it allows the SYCL implementation to adapt your code to your hardware. So now we're going to get good performance on different bits of hardware. And that's where we start to see performance portability. There's only a small number of algorithms integrated into the SYCL standard like this. So what if we want more algorithms? Well, we've got a very similar concept in ISO C++. So ISO C++ also has these standard reduce. And you can say in ISO C++ there's a policy, PAR is our parallel policy. And what this is going to do is this is going to use ISO C++ standards to do basically the same thing. It's going to use a template function and it's going to adapt to the hardware. It's going to parallelize it. But this is only really going to work on CPU. It's quite explicit to CPU. So what happens if we adapt it to SYCL and make it work on a GPU? Well, now what we do is we can do a SYCL malloc to allocate the memory. We can copy the device to the memory. And instead of using the standard C++ reduce, we're going to use the one API DPL reduce. And that actually has a wider range of policies, which allows us to run it on the device. This is open source. You can use this today. And we are working on integrating into one DPL fast algorithms for the different GPUs. And because it's open source, you can integrate, your own FPGA algorithms or any hardware algorithms into that library. So I think this is a really big step forwards. I think this is where we're going to see a lot more work done. I think this is a really good thing for the UXL Foundation because we're combining performance with productivity, because it's easy to write, with portability across lots of different hardware. So this is really enabling us to achieve our aims. Oh, and that's it. I thought I had another section, but I didn't. Okay. Went through that faster than I thought. Have we got any questions?
How there's many compilers out there. How portable is each of these? If you decide to go with one compiler, and then you decide you want to switch because 3 passes versus 1 pass, just as an argument. How easy is that? Is that something you have to think about at the beginning as part of your tool chain?
So you shouldn't. I think at the moment there is a little bit of incompatibility between the different compilers. People definitely manage their code across the different compilers. In Kronos, we have a conformance process where you have to pass all the tests. For the SYCL 2020, which is what people use, I don't think anyone's actually passed the conformance process yet. Hopefully that will change soon, and then that will force consistency between the different compilers. So definitely people do manage to write SYCL that runs on different compilers. I think at the moment people tend to optimize a bit for one processor or another without thinking too much about cross-platform portability. But I don't think there's much to fix. We just need to get that conformance process done, get the compilers through the conformance process. And I think we end up with much more consistency. So we're close and we're getting there. We will fix this.
That sounds like the byline. UXL Foundation. We will fix it.
I think we are still going to have to go through a discussion of how do we, because SYCL is going to develop over time, how do we make sure that we stay consistently compatible? So my view is that we have to maintain testing across the different systems. We have to make sure that the UXL Foundation does not take SYCL into off in a different direction, that it's more focused in the implementation work, getting it working on different compilers, on different hardware, testing, and the ecosystem around it. So we've got libraries that work on all of the ecosystem. One of the big discussions that I want to have in the UXL Foundation right early on is how are we going to keep this consistent? So how do we avoid people forking and going off in lots of different directions so that you do have that consistent developer experience? For me, one of the big answers is public testing. it's kind of name and shame, really, in some ways. It's like, you put the pressure on and go, right, we test this. The challenge that we've got is that when you go to the accelerator ecosystem, the performance boost that you're getting is probably achieved by removing some generality. So not all devices will have the same capabilities. Like, for example, if I was designing a vision system for something like a car, would I put floating point into the processor used for vision? I probably wouldn't, because it's not going to help very much with vision, right? So I would have a very efficient processor that uses fixed point integer arithmetic. I still need to be able to program that in a consistent way. So I think we need to manage that. Whereas, if I'm writing a supercomputer application, I need double precision for everything. Hard to get away from that. I know in machine learning, people tend to use 16-bit precision for a lot of things. So I think we need to work out what portability means in this context and what developers should expect from portability. But it does help that you can write the code once and run it on different things, assuming the feature is there. Was that too long an answer? I think the point is that it's a really important question that we've got to get right. We've got to get right, and we've got to be able to communicate developers. This is what we're doing. But we've got to get everyone lined up so that everyone agrees to this. We are going to be disciplined to this extent. This is the process that we're going to follow. This is how we're going to make sure this works for developers reliably.
That makes sense. I think the portability issue is, especially if people want to do shippable code as part of an application or things like that. I know from a toolchain perspective, like I compile the open source VPC++ compiler all the time, and one thing that I would like to see change, not to make this some sort of shedding thing, but is that the compiler is installed in place, meaning within the install. It doesn't get installed in /user or /user live, right? I have tried to do this, but I've not been able to. And that makes it harder because you have to source LD library path. You have to do these various contortions to make the application run, which I feel like is a barrier to portability in this sense, because I can't ship my development environment across like that. So an observation.
I am keen for. I see that as a packaging problem. I'm keen for us to work out a packaging group to work out, okay, how do we package the compilers in a way where, yeah, it's in a consistent, reliable place, and it's easy to ship your application with. Yeah. Absolutely.
If I may, something I'm kind of curious about is SYCL is sold, like I'm already sold on SYCL, but SYCL is selling itself on, here is a superset of C++ that is meant to run on accelerators instead of being CPU only.
Yeah.
Right. But then we're also seeing efforts within Working Group 21, within ISO C++, to bring in projects like Proposal 1473, standard BLOS, right? To pull BLOS away from what was the old Fortran, unofficially Fortran spec, and pull that into the language. And at the same time, we're proposing all these algorithms that are part of the SYCL superset. So one of the concerns I'm having right now, on top of, say, standard parallelism, is from a developer standpoint, does this push implementations to have to be doubling and redoubling their efforts just to present similar but undeniably distinct code paths in different ways? And does that essentially force out smaller implementations to the point where you can only have a vendor supported toolchain, right? Because we can talk about open source, But one of the problems we've had with, say, open source compute stacks is, if you look at Rockham, for example, is the model of you have a vendor chucking source code over the fence, as David Arlisle once put it. And that doesn't actually get you anywhere. So are we getting to the point where SYCL, as a superset of a large spec already, cannot have a small implementation, and you have to have a big vendor to make it viable at all?
Okay, yeah. So this is a good question. So so one API does have BLAST libraries in it, for example, and it has this one DPL, and it has DNN libraries. The SYCL spec does not. So the SYCL spec is just the language. I think the original one API vision was that there's a one API spec and then people would implement it. But then it became clear that it was just too much for everyone to re-implement all of the one API spec for all the different hardware. And that's why I think it's the direction of travel now is for it to be an open source project where you can integrate vendors, hardware specific optimizations. And so I suppose a question from that is like, when you look at these components, should one DPL and one MKL, which has got the BLAST library, and one DNN only work with the DPC++ compiler, or should they work with other SYCL implementations like adaptive CPP, isn't it? I would like them to work with other SYCL implementations, but there are technical challenges to work out what that means. But I think that's a good question. So one of the things that Codeplay has been doing is some of the implementations of some of the one API specs were implemented in a way that were quite single vendor only. And so you could implement them. I mean, you could implement the specs in lots of different ways, but you'd have to re-implement them from scratch. So we've been implementing libraries called ports. So we've implemented port BLAST, and there's some other ones coming that are open source that should build with any SYCL compiler, and therefore the same library should work with other SYCL compilers. Have I answered your question? It's a long way of answering.
Sort of. I realize it's a larger question, and it's hard to answer over a 5-minute direct Q&A. So it gets to it. It gets to it.
I think you bring up an issue that I'm concerned about and that we are working on. So if all, for example, if all the libraries are written in SYCL, then therefore they should run on any SYCL compiler.
But they aren't.
So that is, to the extent that we can, Codeplay is fixing that, and hopefully other people will help with that. But that's an open discussion, because every hardware vendor does want to be able to use hardware-specific features that are maybe not very programmable, that allow you to accelerate things like matrix multipliers or convolutions. So therefore, how do you integrate that in? And so that's why we need to have a discussion within the UXL Foundation about how we plug those different pieces together.
Gotcha. Specifically, if I can kind of pull us back to the question from about halfway through the talk around packaging. I was speaking to someone at Valve the other day, and they've been actively interested in SYCL. But one of the problems they're having is, A, the packaging issue brought up earlier, but also how cross-platform SYCL actually is in its implementation, right? Because for so it's Valve, so obviously the target is games, but how would a game actually package itself to hit Windows SYCL libraries, right, that run on everything? Like, I've been watching what Codeplay's been doing, and that it's really interesting work. But although I'm an HPC guy, I sometimes worry that there are too many HPC people in the room, and we're only looking at it as, oh, okay, can I port and can I have my code run from one cluster to on vendor A to, when I get an upgrade and a contract 4 years from now, run on system from vendor B and still have it run, right? Not, I need to ship a binary to 1,001 different configurations, including different operating systems.
Yeah. So yeah, I agree with all those things, and in this sense, that is a problem for UXL Foundation to discuss, and I think that's a problem for the packet from a packaging point of view for the UXL Foundation. How do you ship your application in a way that makes it easy to to get it to work on different operating systems. It's not, packaging is not normally something that's included within Kronos specs because the system is often considered part of the operating system. And so the operating system has its own packaging, whereas the SYCL and the ecosystem around it, it's not necessarily considered part of the operating system. So we have to work that packaging question out.
I can, oh, sorry, and just to answer the question in the spec, SYCL does run on Apple. The problem is Apple GPUs specifically. They can run on CPUs.
So I would love to fix that problem. And I'm hoping that part of the UXL Foundation, given everything's open source, that we can do that. We compile down SPIR-V, and I think there are open source tools that can compile from SPIR-V to Apple's Metal. So in theory, it should be possible. I would love to see that project happen. And I'm hoping that UXL Foundation, because it's seen as, because it's industry independent and a foundation, a part of Linux Foundation, it makes it more attractive for open source developers to get involved and do a project like that. It'd be great. Really great.
I have one other comment on the packaging. Seems to be me and Felix's favorite topic. But there's a huge opportunity if you do fix the packaging, especially since I'm really involved in the app ecosystem, the Linux app ecosystem. The ability for, let's say, desktops to be able to use heterogeneous computing between GPUs and CPUs and be able to drive applications is a huge opportunity across at least from Linux apps, right? Because I suspect from an open source perspective, we're going to be behind on the AI, and being able to say train algorithms and then being able to apply them in open source contexts and on desktops like GNOME and KDE is something I am personally very interested in. There's a huge opportunity.
It would be great. I mean, desktops and laptops, the GPUs are pretty powerful in them. Being able to use them, you get extra performance on your desktop and laptop. And if we make it easy to use, I think there's a lot of benefit to it.
Yeah.
Felix has made a commenting chat that I'd love to know more about.
Oh, yeah. I don't know if Carol made it this week. But Carol Herbst of Red Hat and Mesa specifically has been doing a lot of work on a project called Rusticle, which is a Mesa Rust-based implementation of OpenCL that is now planning to be the universal OpenCL implementation across distributions supported by Mesa, notably cutting out the mistake that was Clover. And allowing universal OpenCL across implementations. So that means on Iris, so with Intel, that means with AMD, that means eventually with NVIDIA, hopefully, and work towards Apple GPUs with Asahi Linux. So notably, one of the things that Carol's been working with, and I think he's spoken to Sri, and Sri's connected him with some of the Intel folks about this, has been SPIR-V ingest and outgest, where the plan is to have SPIR-V ingest within Mesa more broadly and within Rusticle as a runtime. And from there, once we have Rusticle on Asahi Linux and we have SPIR-V ingest fully working, which the former of the two is now merged in. It's not deployed, but it's merged into master to the main branch. That means we should be seeing SYCL on Apple hardware under Linux, under Asahi Linux specifically in the coming months, probably by end of year, hopefully. We'll have a hello world of, say, simple dot products going, hopefully. Knock on wood and all that fun stuff. So,
excellent. Looking forward to that.
That'd be great. We have a recording of that and happy to share that internally.
Yeah. Okay. Yeah, I'd like to see that.
You gave a nice talk about that back in June. And maybe I'll throw it out in Mastodon again or on Twitter, that recording, if there's interest. I had one other question, but we're kind of running out of time here. We have 4 minutes. Does anybody have any final questions for Andrew? Okay, well, I want to give people time to, if they have other meetings or things, to take a break and move on to their, for those of you who are here in the American time zone, or give them a chance. Andrew, thank you so much for taking your time and having talk to us on our meetup. I really appreciate that. And if some of you are also interested in speaking here, please let me know. I'd be more than happy to accommodate you all. So once again, thank you, Andrew. Everyone have a wonderful day, and we'll see you next time.
Great. Thank you.
Thanks, Andrew.
It's been really interesting. And do get involved in UXL Foundation. I know it's not quite so clear, but we will clarify it. It's going to be very easy to get involved. So this feedback's been really great.
Yeah, absolutely. I think that would be I think wonderful for all of us to get involved and participate. So,
yeah.
Thanks, Sri. Thanks, Andrew.
Thank you. Thanks, Andrew. Bye.
Thank you.
Y'all have a good one.
And there will be a recording, so I will publish that.